So when we were proving the thing about the petals, we were proving, and which became something about a regular hexagon being circumscribed in a circle, during that we used these theorems, right?
Yes.
All equilateral triangles are equiangular, the sum of angles of a triangle is 2 right angles, and so on. And there were a few more apart from these. However, how do we know these are true? We've assumed that they're theorems.
Yeah.
Because we've heard of them before or for whatever reason.
So if you doubt and question any of these theorems, which you should, then we should provide a proof.
Yeah.
Okay.
So let's ignore most of these for now, but let's take theorem number 2. The sum of angles of a triangle is in a triangle is 2 right angles. Now it's a conjecture, it's no longer a theorem. Because we don't know whether it's true.
Okay, let me write this. The term that people know is, this is called angle sum theorem. So if they look it up on Google or YouTube, that's the terminology that they're familiar with, angle sum theorem.
Yeah.
Okay, how do we know it is true? Can I erase this one then?
Yeah.
We don't need this, right? Okay.
So how do we know this is true? So let's draw a triangle.
Should I erase this tree? Yeah.
Yeah, we can erase this. An arbitrary triangle. A, B, C. The vertices of the triangle, label A, B, C.
Yeah. Well, one way of doing that is say, measure this angle, measure this angle, measure this angle.
And add them together.
Add them together for a large sample.
Yeah.
Yeah. That will not.
Another way of doing it is cutting out these bits and putting them
yes,
side
that's
by
the one
side.
that many students actually use in schools.
So you take B, you cut out that bit, you put it here, you take A and you put it here, and you'll see that it'll turn out to add up to, it'll become a straight line.
Let me take a piece of paper and do that actually. I don't know if I have a piece of paper. Yes, here's a piece of paper. And demonstrate that. So here's a piece of paper and I draw a triangle like that and I cut it, I guess I can cut it like this, right? Okay, so here's a triangle. Here's a triangle, and what I do is I cut this angle, hold it, and I cut this angle, and I cut this angle, and put this together.
And you see it's kind of a straight.
That's your fingers.
Yeah.
Okay. So this is a okay. If you put it right, which we are not doing quite, you will see that this is a straight line. And straight line has 2 right angles.
Yeah. If you leave it, I think now we
Yeah.
can see. The straight line has 2 right angles, so this is proof. But is it proof? This would, if you do this many times and it works, this would count as a scientific proof once again.
Yeah, what they call it a visual proof. Actually, if you look up,
if you do it once, it's not even a scientific proof.
Yeah, just accidentally one of them. But if you do it 100 times in different cases, that will also be like sample.
Yeah, that would be a sample. So let's try proving it mathematically.
Yeah. So this is not mathematics.
No, that's not mathematics.
Yeah.
So what you do is you draw a line parallel to AC going through B.
Okay.
Call it D, E. So the first step is draw a line DE parallel to AC passing through B.
So you're assuming that this is possible.
Right now we're just going forward.
Yeah. That's the first step.
So this is now parallel to this, right? So we know by the alternate
Interior angle,
angle property that this angle equals this angle.
Interior, after 1 it is number 2. Interior alternate angle. By that, you're saying
this angle,
that is
DBA
is
equals
congruent
angle BAC. BAC.
Okay, so this one is equal to this. Okay.
And you get this is equal to this by the same property.
Okay, so EBC is equal to
BCA.
BCA. Okay.
Yeah. So this is the same as this. So let's say this is 1 and this is 2. Then this is 1 and this is 2. And then this be 3.
Okay.
So you have 1 plus 2 plus 3. 1 plus 2 plus 3 equals the angle of the straight line, which is two right angles.
Two right angles.
And 1 plus 2 plus 3 is also the sum of
triangles. That should be two right angles.
Two right angles.
Okay. So can I write then QED, that which has to be proved, has been proved.
You can do that, but the problem there is, how do we know that this is possible?
So you question this.
Yeah.
I can also question this.
Yeah. How do you know that the interior alternate angle property works?
Right. That's a good question.
Yeah.
So every time you prove something, there are other things.
There are other things. So you saw when we were doing the petal proof, we saw that there was this statement that the sum of angles in a triangle is two right angles. Now we have to prove that. We proved that using these two things. Now we have to prove each of these two things.
Okay.
Right?
So how do you prove this?
So this one is actually in Euclidean geometry. Sometimes the fifth postulate is stated exactly like this. So the axiom. This is we had mentioned the fifth postulate earlier. This by axiom is true. By that axiom is true.
It is like that is to say this is one of the starting points
for Euclidean geometry,
which is the fifth. I'm going to call it fifth axiom.
Yeah.
Which means for every line
parallel
and the point outside it, it is possible to draw exactly one parallel line.
Yeah. This is the axiom is taken in many different ways. So sometimes it's stated like this. So let's go with that statement of the axiom. And
so we call this as axiom, and so since that's the starting point, we accept it.
Yeah. Now we have to question this, but we're going to leave that to the viewers to work on.
Tell me another way of stating the fifth postulate.
So another way of stating the fifth postulate is if you have this line going through
two lines and another one.
Two lines and another one. If the sum of these two angles is less than 180 degrees,
two right angles.
So less than two right angles.
They will meet at that.
They will meet at that. If this is less than two right angles,
it will meet here.
Yeah.
So if it is like this, this will be less than two right angles. So and this will meet somewhere if you extend it.
Yeah. So this is another way of stating it, that the sum of these two should equal to the sum of these two, which equals two right angles.
Okay, so essentially what that means is, another way of stating it is, if there are two parallel lines, then these two will meet two right angles.
Yeah.
Right?
But therefore you'll get the other one.
Okay.
Yeah.
So there are different ways of stating this.
Yeah.
All of this has to do with parallel lines, essentially. Yeah. Okay. If you take one of them as the axiom, the other one will be a theorem. Okay.
So with this we'll leave.
Yeah.
And I think this.
Don't you also need to know what a triangle is?
Yeah.
Because the statement is about the sum of angles in a triangle, right?
Yeah.
What is a triangle?
Yeah. So
You have to define that.
We have defined what a triangle
Yeah.
is. So let's actually try and do that. So a triangle would be a closed shape bounded by straight lines. Bounded by 3 straight lines.
3, because otherwise you will say this is also a
Yeah.
triangle.
So bounded by 3 straight lines.
Yeah. So
3 and only 3 straight lines, because
Yeah.
otherwise this
That's
would
right.
also be a
Right.
triangle, right?
So that you can avoid by saying a triangle is a polygon.
Yeah. Or you can say
Then
triangle is a polygon.
polygons
And
are
then
bounded only
polygons
by-
are defined in a certain way, and you get.
So a triangle is a 3-sided polygon.
Yeah.
We'll do it. Okay.
Yeah.
So essentially what you're saying is any theorem, if you want to prove it and you prove it in terms of existing theorems,
Yeah.
you question those, and so on. Ultimately you get to axioms and definitions, which is what we started out with
Yeah.
in response to what is mathematical inquiry.
Yeah.
Okay.